So we're going to be dropping several things off of a tall building today, and one of the things that we'll be doing is we will be dropping basketballs of different sizes from the buildings. This is a standard regulation basketball over here, and this is a smaller basketball, about 1/6 the size, and note the major difference in diameter. That's going to be important in our explanation. Then we're also going to be dropping some other balls off of the roof. We're going to be dropping 2 balls of this size. This is the lacrosse ball, quite solid and massive, and this is a wiffle ball over here, and obviously it's about the same diameter, but it's much different mass. And then we'll be doing another drop of these 2 balls right here. This is a standard issue golf ball, and this is a so-called golf practice ball over here. We're also going to be making physics fruit salad today, and we're going to be dropping several different kinds of fruit off of the building to see what happens. We'll be dropping some large watermelons here. This is a seedless watermelon. It weighs about 12 pounds or so. This is a mini watermelon. It has about half the weight. It weighs about 5-6 pounds or so. And then in combination of that, we'll also be dropping different fruits that are smaller. For example, we'll be dropping a lemon, and then a cherry tomato, which in this case is kind of beat up a little bit, but we'll be dropping intact ones when we actually do the experiment. So that's the background behind what we'll be doing, and now all we need to do is we need a building to drop the fruits off. The first objects we're going to drop will be the 2 basketballs of different sizes, and you can see them up there in the window of our insectary here, and on my signal they're going to drop them. Ready? Drop. And what you saw there was that the balls came down at different positions. Part of that was due to being released at slightly different times. And we can correct for that when we analyze the motion a little bit later. The next objects we're going to drop will be the lacrosse ball and the lighter wiffle ball. We'll just wait for the traffic to clear and the wind to die down. Ron, ready? Let it go now. Well, as you can see, they came down at markedly different rates, and we'll see this again and again in the different kinds of objects that we drop. The next objects that we'll drop will be the golf ball and the small wiffle ball. Ready, Ron? Drop now. As you've seen, the 2 balls come down at markedly different speeds, and we'll have to analyze this more carefully to see if size makes a difference, but you see the point consistently. Heavier balls do actually fall faster than the lighter balls, as long as they're the same diameter. The next object that we're going to drop will be a large watermelon and a small watermelon. Okay guys, get ready. Ready, drop, on cue. Now that had a rather spectacular end, but again you saw that they came down at different speeds. Again, we'll have to analyze it much more closely to be able to parcel out what's going on, but they did come down at different speeds. Okay, the next object we're going to drop will be a large watermelon and a lemon. Okay guys, ready, drop. That was interesting. It looks like the lemon actually came down faster. Okay, and finally the object we'll be dropping will be a large watermelon and a small cherry tomato, and we hope we'll be able to see the cherry tomato. Okay guys, you ready? Ready, drop. And again, quite a spectacular difference of velocity. Now, obviously, the ancient physics that Galileo was talking about, they had a point, and you can kind of get a feel for the obstacles that Galileo was facing. Here's very clear experimental evidence that indeed bodies that are different in size and maybe mass do actually fall at different rates. And so what we need to do is we need to look into the motions, the forces that govern falling bodies in some more detail so that we can explain this result and make it consistent with what Galileo himself